Alright guys, welcome to another video here. What we're going to be looking at today is building on the knowledge that we had in the previous videos on calculating resultant force, etc. But what we're going to do here is we're going to calculate resultant force in a system where there's three forces acting on a component or on a mass of some description. So we're going to look at resultant force and also line of action, which is something that we haven't really touched on just yet, but we're going to start to work our way through this. Now, as I mentioned in our previous videos, getting yourself nice and neat and organised is step number one in solving any of these problems, because if you've got text all over the place, you've got to get your layout right, otherwise you'll soon get confused. So all I've done here is I've laid out a little list of all the forces I've got. I've got three of them. I've got my total on there, and I've got a resultant on the bottom, and I've got horizontal and vertical in columns. So I'm going to start to sort of lay out the solutions to this, and then we'll work our way through and we'll calculate resultant, and then we'll move on to the next section, which is to calculate a line of action. Now, as we can see, we've got three arrows here. Okay, so we've got number 1, number 2, and number 3. Alright, and those arrows are pointing in different directions. So we're going to use our cos and sine for taking the force value for force number 1 and split it up into its horizontal and then its vertical components. So to do that, we take the force, which is 15. We use cos for horizontal, or you might see that written as x and you might see that written as y, but cos, and the angle that we need is this one here, this 40 degrees. Okay, now that 40 has got nothing to do with that 20, it's only relating to that 15 equals. And we'll do the same on this side, except this time we'll use 15 sine the angle, and that'll be equals. Okay, so you can pause the video and you can calculate those. Okay, so hopefully at that point you realise your calculation will say that you've got 11.5 there. Now we're only going to use three significant figures on this, that's plenty of accuracy. We'll use three significant figures all the way around. Obviously if you use 4 or 5, then your answers might be slightly different when you get to the end, but in this example three significant figures is plenty. And on this side we get 9.64. Now again, I'm not putting the units on these, just to keep my screen as nice and as clean as possible. I'll make sure when I get my resultant force at the end, I've got the units on that. So the next one I'm going to do is I'm going to have a little look at this 20 Newton force. So I'm going to do 20 cos the angle. Alright, now that 20 Newton force is acting in a horizontal direction along the horizontal plane. So in actual fact there isn't any angle there. So 20 cos 0, and then on this side we're going to have 20 sine 0. Again, you can pause the video, pop it into your calculator. Alright, so what we should have here is a value of 20 sine 0, we're going to get a value of 0, because as you can see that arrow is pointing to the right, so therefore that is a positive force. There's nothing going vertically, it is only going horizontally. Okay, and it's only going to the right, which makes it positive. Next one we're going to do, force number 3, again layer 10 cos, and the angle this time is 30, and we'll have 10 sine 30 on the opposite side. Now again, you can pause the video, calculate this one and that one. Okay, 8.67 on this side, and then 10 sine 30, we should have 5. Okay, now I'm going to come back to my force system again, and if you remember rightly in our last videos and our last learning, any forces that are going towards the left along the horizontal axis are negative forces. Okay, so therefore this answer must have a negative in front. Now you don't need to put your negative in front of your 10, or you could put it in front of your 30. You do need to remember to put your negative in there, but if it makes it easier for you, you can pop your negative in the front, in front of your 10 or in front of your 30, and that will give you a negative in your answer. There is another technique where we could change that to 10 cos 150, and then that would give us a minus. Now the reason that we don't have a minus on this side and we have a positive is because it's positive in a vertical direction. Alright, now remember our next section, our next task is to find the sum of these forces. Now that doesn't mean adding them up, it means finding the sum of them. So whatever we've got in front of that is what we're going to apply. So we're going to have 11.5 plus 20 minus 8.67 equals, and on this side we're going to have 9.64, again positive, plus 0 plus 5 equals. Okay, nice simple maths here, adding those values up or finding the sum of those values. We should get 22.8, and on this side we should get 14.64. Right. Next section, calculate resultant force, and that is taking our old mate a squared plus b squared equals c squared and rearranging it, or let's rewrite it, fr equals fh squared plus fv squared, and then the square root of that will give us fr. So that's the formula we've got. It's our Pythagoras theorem rearranged, but using the force values instead of a squared plus b squared equals c squared. So nice and simple done here. We're going to get fr equals the square root of fh 22.8 squared plus fv, we've got 14.6. I've put a 4 on that. We'll leave the 4 in just now, even though I did say 3 single figures is plenty. And that's going to equal, again we'll pop that into your calculator, see what answer we get. So that's going to equal 27.1 newtons. So what we've got here is we've got the magnitude of the resultant force. Magnitude being how big is this resultant force. So for this question here we've got 27.1. Alright, now next thing we're going to have a little look at, I'll jump into the next page here, is line of action. Alright, now I use trigonometry again. Sine we use for our vertical, cos we use for our horizontal. So in this occasion, to calculate the line of action or the direction that this resultant force is acting, we're going to use the last trigonometry function of tan. Okay, now again you remember from your GCSE maths, tan opposite over adjacent. Now you might find it easier to lay out a little triangle when you're calculating direction of resultant. Alright, we'll label these up. So we've got our horizontal on this side, yeah, which would be the adjacent, and then we've got our opposite on this side, which was our vertical. Okay, now if you go back to the previous page, you see that the horizontal has got a value of 22.8 here, and the vertical is 14.64. So I'm going to label these up. Horizontal 22.8, vertical 14.6. We'll leave it as 14.6 in this case. So what I'm actually trying to do here is to calculate this direction, is to find out what this angle is. Alright, now again if we label these up, that O is for opposite, A is for adjacent. We already know what this side is. This is our resultant force, or if we're talking about trigonometry we'd call that our hypotenuse. Okay, so you might find it easier to calculate your direction if you've got a little triangle set up like so. Now I'm going to use the tan function in my calculator, but I'm going to calculate an angle, so I need to do that shift tan, and I'm going to take the vertical and divided by the horizontal. So again the O and the A. Alright, So that's what my formula is going to look like when I'm calculating direction. So I'll pop the actual values in here. Direction, vertical 14.6, divide that by the horizontal 22.8. You can close those brackets, although if you press your equals on your calculator, it would actually work out for you, but if you close the brackets it might make it easier for some case. And so what we've got here is we've got a direction of 32.7. Now that relates to this angle, okay, so opposite and adjacent. So our resultant force, FR, just to make this nice and neat here, is 27.1 newtons. Well, it's more like a W, but let's call it newtons. And the angle, or the direction, equals 32.7 degrees. Okay, so if we don't prevent this system, if we don't put a resultant force in this system here, then what will happen is this system will move off at an angle of 32.7. And so there we go. So we've got our resultant and our direction. Alright, now what I'd like you to do is I'd like you to have a little look at this next question and work it on your own. Now please just follow those same steps. Yeah, we've got three forces there, the 30, 35 and 20. We've changed the angles, but what I'm wanting to do is try and build up some practice solving these problems. So I'd like you to have a little go at that yourself. You can take when you've finished it, take a picture, send it to me through the VLE, and then I can have a little look at it for you, and if there's any major problems then I can let you know. But obviously the only way you're going to get sort of practice at this is if you sit down with a pen and a bit of paper and start to work through some solutions. So hopefully that'll make life a little bit easier for you. But as always, let me know if you need any help, and see you next time.